We're diving into a topic that might sound like it's straight out of a sci-fi movie, but it's real and quite serious. NASA has issued a warning about a potential planet-killer asteroid that could hit Earth. Let's break down what we know, what NASA is doing about it, and what it means for all of us. Imagine you're sitting at home, scrolling through the news, and you come across a headline that reads, "NASA warns planet-killer asteroid to hit Earth." It sounds terrifying, right? But this isn't just some clickbait headline, it's a genuine concern backed by years of astronomical observations and calculations. First, let's talk about what exactly a planet-killer asteroid is. We're not talking about the small meteors that occasionally light up our skies as shooting stars. No, we're talking about massive celestial bodies, often several kilometers in diameter, capable of causing widespread devastation. If one of these were to collide with Earth, it could lead to catastrophic events, including tsunamis, massive fires, and even changes to our climate. NASA has been monitoring near-Earth objects (NEOs) for decades. These are asteroids and comets with orbits that bring them close to Earth's path. NASA's Planetary Defense Coordination Office is tasked with identifying and tracking these objects to determine if they pose any potential threat to our planet. Over the years, they've developed sophisticated systems and telescopes to detect these NEOs well in advance. One of the most significant tools in this endeavor is the Near-Earth Object Wide Field Infrared Survey Explorer, or NEOWISE. This space telescope has been instrumental in discovering and characterizing asteroids that come near Earth. Thanks to NEOWISE and other observation programs, NASA can predict the paths of these objects with increasing accuracy. Now, onto the main event, the asteroid in question. It's called 2023PZ39. According to NASA's calculations, this asteroid is on a potential collision course with Earth. While the chances of a direct hit are low, the sheer size of this asteroid, estimated to be around a kilometer in diameter, makes it a significant concern. If 2023PZ39 were to impact Earth, it would release energy equivalent to hundreds of megatons of TNT, far more powerful than any nuclear weapon ever detonated. So, what is NASA doing about it? One of the key strategies in planetary defense is to study these asteroids in detail. By understanding their composition, structure, and orbit, scientists can develop potential methods to deflect or disrupt them. This is where missions like OSIRIS-REx come into play. OSIRIS-REx recently returned samples from the asteroid Bennu, providing valuable insights that could help us deal with future threats. Another groundbreaking initiative is the Double Asteroid Redirection Test, or DART. This mission involves sending a spacecraft to deliberately crash into an asteroid to change its course. In 2022, the DART mission successfully impacted the asteroid Dimorphos, altering its orbit. This demonstrated that we have the capability to deflect potentially hazardous asteroids, but what if an asteroid is detected too late for deflection? In such scenarios, evacuation and disaster preparedness plans would be crucial. Governments and international agencies would need to work together to mitigate the impact's effects, which could range from regional devastation to global climate disruptions. It's also worth noting that while the idea of an asteroid impact is frightening, the probability of a major collision in our lifetime is extremely low. NASA and other space agencies around the world are continuously monitoring the skies, ready to take action if a threat emerges. The advancements in space technology and planetary defense are a testament to humanity's ability to tackle even the most formidable challenges. Let's delve deeper into the science and technology behind asteroid detection and deflection. NEOWISE, launched in December 2009, has been a cornerstone in our ability to detect near-Earth objects. Initially a mission to survey the sky in infrared light, it was repurposed in 2013 to focus on NEOs. Since then, NEOWISE has provided invaluable data, discovering hundreds of NEOs, including potentially hazardous asteroids, PHAs, that could pose a threat to Earth, but NEOWISE is not working alone. Ground-based observatories play a crucial role in this global effort. Telescopes such as the Pan-STARRS, Panoramic Survey Telescope and Rapid Response System, in Hawaii, the Catalina Sky Survey in Arizona, and the recently upgraded Arecibo Observatory in Puerto Rico have all contributed to the discovery and tracking of NEOs. These observatories scan the skies nightly, looking for any objects that might come close to Earth. Once an asteroid is discovered, astronomers calculate its orbit to determine if it poses any risk. This is done using sophisticated algorithms and data from multiple observations. The Minor Planet Center, funded by NASA, collects, checks, and disseminates these observations, providing the scientific community with up-to-date information on NEOs. Now, let's discuss the potential impact scenarios and preparedness strategies. If an asteroid were found to be on a collision course with Earth, the first line of defense would be to try and deflect it. This is where missions like DART come in. The DART mission, part of the IDA, Asteroid Impact and Deflection Assessment, collaboration with ESA, aims to test our ability to change an asteroid's trajectory. By impacting Dimorphos, a moonlet of the asteroid Didymos, DART successfully demonstrated that kinetic impactor technology could alter an asteroid's orbit. This proof of concept is vital for developing future deflection missions that in addition to kinetic impactors, other methods are being explored. One such method is the use of gravity tractors. This involves sending a spacecraft to fly alongside the asteroid, using its gravitational pull to slowly alter the asteroid's path over time. While this method would require more time to be effective, it offers a non-destructive way to nudge potentially hazardous asteroids away from Earth. Another innovative approach is the use of nuclear devices. While this might sound like a plot from a Hollywood movie, the idea is not to blow up the asteroid, but to use the explosion's energy to vaporize part of the asteroid's surface, creating a jet of gas that would push the asteroid off course. However, this method comes with significant political and practical challenges, not least of which is the need for international cooperation and agreements on the use of nuclear technology in space. But what if an asteroid is discovered too late for deflection? In such a scenario, disaster preparedness becomes crucial. Scientists and policymakers would need to predict the impact zone as accurately as possible and implement evacuation plans to move people out of harm's way. This would involve coordinating with local and national governments, emergency services, and the general public to ensure a swift and orderly response. The potential aftermath of an impact would depend on the asteroid's size and composition. Smaller asteroids might disintegrate upon entering Earth's atmosphere, causing damage similar to the Chelyabinsk meteor in 2013, which injured over 1,000 people due to shattered windows and debris. Larger asteroids, however, could cause significant regional or even global effects. For instance, an impact in the ocean could generate massive tsunamis, while an impact on land could create large craters, ignite fires, and release dust and aerosols into the atmosphere, potentially leading to a nuclear winter effect. To prepare for such eventualities, scientists use computer simulations to model the potential effects of asteroid impacts. These simulations help in planning evacuation routes, setting up emergency shelters, and stockpiling supplies. Public awareness campaigns are also essential, as they ensure that people know what to do in the event of an impending impact. Moreover, international collaboration is critical in planetary defense. Organizations like the United Nations Office for Outer Space Affairs, UNOSA, work with space agencies and governments worldwide to develop coordinated response plans. The International Asteroid Warning Network, IAWN, and the Space Mission Planning Advisory Group, SMPAG, are two key entities established to enhance global cooperation in detecting and responding to asteroid threats. It's also worth mentioning the role of citizen scientists in planetary defense. Amateur astronomers contribute significantly to the discovery and tracking of NEOs. With advanced telescopes and software, they can spot new objects and report their findings to professional observatories, adding valuable data to the global effort. In conclusion, while the headline, "NASA warns planet killer asteroid to hit Earth," is alarming, it's important to stay informed and understand the science behind it. NASA's diligent work in tracking and studying these celestial bodies ensures that we're better prepared than ever to protect our planet. So, let's continue to support scientific research and stay curious about the incredible universe we live in. Thank you for watching. If you found this video informative, please like, share, and subscribe to our channel for more updates on space exploration and scientific discoveries. Stay safe, stay informed, and keep looking up at the stars.